Hello, I welcome you all in this presentation related with the subject fundamentals of the surface engineering. And as we have talked that the surface properties affect the performance of the mechanical components significantly, because many times the failure is triggered from the surface. So, it is important to understand what the surfaces are composed of. And therefore, in this presentation basically we will be talking about the various aspects related with the surface and subsurface features. In surface engineering, we target on the two aspects. One is improving the surface characteristics and enhancing the surface properties, so that the life of the component can be improved and it can perform the required functions in much better way. And sometimes surface engineering is also used for increasing the functionalities and capabilities of the component, so that it is able to deliver the required function. Basically, any surface comprises the two aspects. One is the features which are present at the surface, and the second is about the subsurface features. So, as far as the surface features are concerned, what will have, like any mechanical component which is made by one or other manufacturing process like casting, welding, forming, machining, etc., it will have some kind of the irregularities present at the surface. These irregularities present at the surface are normally quantified in terms of the surface roughness, and the surface roughness is normally characterized. There are number of methods to characterize the surface roughness. Like stylus based is one method, and there are number of non-contact based methods nowadays which are used to characterize these ups and downs present at the surface, which are known as surface irregularities in form of, like you say, surface asperities. These surface asperities are also termed as the peaks and valleys present at the surface. So, the height and depth of these peaks and valleys are characterized in terms of the surface roughness, and Ra is the one of the most common parameter which is used to characterize the surface roughness. And normally the machined component offers the surface roughness in the range of like say 0.2 to 4 micrometer, while the polishing and finished surfaces offer the surface roughness even less than 0.1 micrometer. So, polishing and super finishing methods are used for improving the surface finish or reducing the surface roughness. Surface roughness indicates the extent of ups and downs are present, and inverse of this is characterized as a surface finish. Surface finish. So, greater the surface roughness, lower will be the surface finish or the smoothness. We know that the extent of ups and downs or peaks and valleys present at the surface significantly affect the friction and wear behavior of the component, because although there is an optimum combination, very high surface roughness or very low surface roughness both result in higher friction, while the optimum level of the surface roughness results in the good combination of the wear and friction resistance. So, in general, since it is very difficult to achieve very high degree of the surface finish, therefore, efforts are always made to reduce the surface roughness, so that reasonable required degree of the surface finish can be achieved, normally in the range of like say 0.1 to 1 micrometer in terms of the Ra as a roughness parameter. So, this is one aspect, like presence of the surface irregularities and their quantification in terms of the surface roughness is one aspect of the surface features or surface characteristic. The second important aspect is the subsurface features or subsurface characteristics. So, in general any surface comprises 5 different zones at the surface and near surface zones or near surface layers. So, there are 5 different zones which are normally present in all the components, mechanical components made of the crystalline material produced by the conventional manufacturing processes. These are termed as zone 1, zone 2, zone 3, zone 4 and zone 5. Now, we will look into these zones one by one, what these zones will be comprising and what kind of effect will be there in these zones. So, the zone 1 that is which is present just at the surface, it basically it is a very thin zone which is of very few nanometers, and this zone is composed of like absorbed gases, hydrocarbons and moisture. It is very thin, and this is also called contamination layer, and this zone may be damaged or may be removed with the application of the pressure and the heat very easily and effectively. The second zone is made of is next to the contamination layer, is the zone which comprises basically oxides, nitrides, which are formed due to the interaction between the metal of the surface and the surrounding gases like oxygen, nitrogen, hydrogen, etc. And these interactions will be resulting in the formation of their oxides. So, interaction of the metal with the atmospheric gases or the surrounding material or surrounding gases, whatever is present, that will be leading to the formation of this zone, like formation of the rust through the iron oxide formation is one of the typical example for this kind of the zone. And the third zone is damaged zone. We know that most of the metals will have the crystalline structure, and this crystalline structure involves the regular arrangement of the atoms in one particular order, and whenever metal is subjected to the mechanical processes for sizing and shaping or some other kind of the processes, then like say the shot peening or any other process used for improvement, a very thin zone which is formed next to the oxidized or nitrides which are present in the second zone. So, after the first zone there is a second zone, and next to the second zone we have a very badly damaged zone, which damaged zone means the crystal structure is damaged, and this zone is also very thin, it is less than 1 micrometer. And thereafter we have one region which will be experiencing the lot of deformation or strain due to the somewhat more plastic deformation of the near surface layers. We know that the most of the materials, when they are subjected to the processes like machining to get the desired size and shape, the near surface layers will be experiencing some kind of the deformation. Like this one typical example where the surface has been produced by the machining process, and near surface layers will have some kind of the will be experiencing some kind of the strain. This zone may be very thin, like 20 to 100 micrometer, but this deformed zone is always there in, especially in the machine component. So, the zone 4 is this the zone where the plastic deformation is will be occurring to such an extent that there is no damage to the crystalline structure, but the plastic deformation can be seen from the orientation of the grains as well as change in the and the change in the shape of the grains, or maybe hardness of that region will also be different due to the work hardening effect. So, the zone 4 consists a layer of thickness ranging from the few micrometers to the hundreds of the micrometer, with the grain structure deformed. So, the grain structure means the shape of the grain is deformed, and this may happen due to the application of the external stresses during the manufacturing or the development of the residual stresses. So, this is the zone 4, and the fifth zone is basically the zone which is the which will be mainly of the base metal or the unaffected metal which has not been damaged in any way due to the effects of the temperature or by the mechanical forces being used during the manufacturing process, that will be leading to the formation of the zone 5. So, the zone 5 involves the normal structure of the bulk material as per the thermal and mechanical history or the stresses experienced by the metal during the manufacturing. So, this is how we can say there are 5 zones. The zone 1 is of absorbed gases or the hydrocarbons or the moisture. Then we have oxidized zone, the zone having the oxides and nitrites, then very thin layer of the badly deformed or damaged crystal structure. Then there is a deformed zone where there is a change in orientation of the grains, and the fifth zone is basically the unaffected zone. So, since there are a lot of techniques or the processes which are available for modifying the surface properties, since all these 5 zones will be forming the features which are closely associated with the surface and subsurface zone. So, whenever the surface engineering techniques are or surface modification techniques are applied, one or more of these zones are modified or altered, like application depending upon the extent of the effect of the surface modification technique, means the depth up to which the surface characteristics are affected, that will be changing these zones as per the kind of process of the surface modification being used. Like few modification processes, they will be working, they will be affecting the zone 1 and zone 2 only, which are very thin. Few will be affecting the zone 1, 2, 3, and few will be affecting zone 1, 2, 3, 4 also. So, depending upon the extent of effect, because zone up to 4, this may be of like say depending on the process, this zone may vary from 100 to like say 500 micrometer. If the machine the component is very badly machined, if abused machining is performed, this zone, the zone 4 may be very wide, and fine finishing will be leading to the very thin zone of the zone 4. So, maximum the depth from the surface like 40, 50 or up to 100 micrometer in case of the finished processes, or the polished surfaces will be leading to the further thinner zone of these further finer thickness of all these zones. So, the point is here, whenever the surface modification is carried out, one or more of these zones are modified during the surface modification process. So, the surface engineering or modification will be involving the modification of these one or these more of these zones. Now, one more important thing, as per the kind of approach which is being used, whether the heat is being applied or the forces are being applied during the surface modification, as per the extent of effect of these aspects, the different kind of the changes will be occurring. Like application of the heat may be leading to the removal of these absorbed gases or the moisture and hydrocarbon. Even the thermal decomposition of the oxides present at the surface layer can also take place. Similarly, the mechanical forces, use of mechanical forces can lead to the very large scale damage to all these zones which are present at the surface, and leading to this significant deformation of the surface and near surface layers, leading to the significant work hardening effect, increasing the hardness, and so the mechanical properties of the component. Now, as we have seen that each surface will be composed of the two aspects. One is like the features which are present at the surface in terms of the the surface roughness RA, or in terms of the kind of the subsurface zones which are present below the surface. We need to for improving the performance of the mechanical component, it is required that the suitable changes are brought in the metals, brought in the properties of the surface. Suitable changes are brought in at the surface properties. So, now which kind of the changes we should bring in, that will depend upon what we are looking for, and what kind of changes we should have, means what properties we should have at the surface after the modification, that will be governed by the application, because application of the surface for a particular situation will determine what kind of conditions it will be experiencing, and accordingly the properties it should have, that will be dictated. So, but in general, if we see the performance, tribological performance in terms of the wear resistance of a mechanical component is influenced by these following 4 group of the properties. So, the tribological performance which is affecting or determining the life of the component under the wear condition is dictated by these 4 group of the properties. The group 1 includes the physical properties, which may be in terms of like the melting point or resistance to thermal softening, or it may be in terms of the thermal expansion coefficient. Similarly, the mechanical properties like hardness or the fracture toughness or the percentage elongation. Similarly, the chemical composition will also have the chemical properties will have composition or affinity to the gases, affinity to the gases which are present, or like in form of oxygen or the nitrogen or the hydrogen, how quickly and how the given surface of a given material reacts with the gases which are present all around in or the environment in which component has to work. And the dimensional properties, primarily it is the surface roughness, like straightness, flatness, and the like the area which will be under the which will be exposed during the surface. So, these are the broad categories, the 4 broad categories of the properties that will be determining the way by which the loss of material from the functional surfaces will be taking place. So, functional surface will be taking place. So, if the properties are dictating, the combination of the surface properties like physical, mechanical, chemical or dimensional property combination for a given component is such that the rate of material loss is very limited or very low. The rate of this loss is very less, then means the low rate of material loss indicates that it will take long to have any significant change in size and shape of the component. So, components will continue to perform for long and will result in the longer life of the component. Under the different service conditions, the different operational wear mechanisms will be present, and as per the operational wear mechanism, different combination of the physical, chemical, mechanical and dimensional properties will be required. So, first of all we will be looking into the physical properties and the way by which the physical properties can affect, what are those physical properties and the way by which they can affect the surface performance. There are two types of the physical properties. One is which are primarily used which are primarily designed in a particular component in such a way that it reduces the wear rate. But there are certain properties like optical properties, absorption, solar system, this and the reflection of the radiations. I will talk in detail about these later. First of all, what we will see that the thermal conductivity. Thermal conductivity will be determining how fast the heat will be transferred from the region wherever heat is being generated due to the frictional effect in travelogical system. So, high conductivity, high K means the first greater ability of the material or more effective transfer of the heat from the region where it is being generated to the other zones. So, increase in K reduces the temperature of the functional surfaces where heat is being generated. So, the metal is able to retain its properties more effectively and component is able to perform more successfully. Many times it is required in reverse way where low conductivity metals are used, like what we want a component is to be those components which are to be used at a high temperature, like surrounding temperature is 600 degrees centigrade, and what we want, this component temperature should not exceed 550 degrees centigrade. So, in that case we will be covering this component using the low thermal conductivity metal system. So, the heat is isolated, means the component is isolated from the high temperature conditions, and this low thermal conductivity metals will be reducing the transfer of heat to the main component so that it can run under the safe temperature conditions, and for this purpose only thermal barrier coatings are used. So, that is what we can say thermal insulation. Thermal insulation will be used for those cases where either heat we want to preserve or we want that a given component is not exposed to the much higher temperature. So, the heat is not transferred to the component, and this is facilitated by the thermal barrier coating. Similarly, in the heat engines where we want that more and more amount of the heat is preserved and less heat loss takes place. So, inner surface of the cylinders may be coated so that the heat losses, whatever heat is generated by the combustion of fuel, that is preserved and not much loss of the heat to the coolant or to the external bodies takes place. So, it will be performing two functions, heat will be preserved and the surrounding temperature of the cylinders and the pistons or whatever the components which are in contact with the high temperature zone, they are kept within the safe temperature limit. So, it can be useful to have both as per the need we may require. So, for improving the functionality, improving the travelogical life, we may use high conductivity metal systems as well as the low conductivity metal systems. So, low conductivity metal systems are used for improving the thermal efficiency of the component of the thermal systems, and thermal barrier coatings TBC, these are called TBC, and high conductivity metal systems where high thermal conductivity metal systems where it is required that heat is transferred very effectively from one zone to another. Thermal coefficient will be affecting especially where the component is coated with the coating material like this. Like in surface engineering, development of coating and development of layer is one of the common approach. So, if the base metal is having the K value same close to that of the coating material, then coating will be able to sustain the thermal cycles very effectively. But if there is a large mismatch like 12 units of the base metal and 16 units of the coated material, then under the thermal cyclic conditions due to heating and cooling, the coating may spall off or peel off from the surface. So, removal of the coating from the substrate will be losing the function of the surface modification, and the purpose of surface modification will be defeated. So, it is required that the thermal expansion coefficient of the material which is being applied in form of the coating or in form of the overlays, that is almost matching with the base material properties. Refractoriness is important, especially for the conditions where the metal is being applied is able to retain the required properties at a high temperature. So, high temperature resistance. This is important, especially the coatings which are used for in the metal cutting tools for surface modification. Like variety of the coatings are used over the like this is the tool, can be made of tungsten carbide or made of the HSS. So, the surfaces of such kind of the tools are coated with the such kind of materials which can retain their hardness at a high temperature. So, because hot hardness is important during the metal cutting, lot of heat is generated, and that heat will be softening the tool materials as well as the material whatever is present at the surface. So, if the coating is applied on these materials, then that coating should retain its hardness to perform the desired function successfully, and that is why as per the application, it is important that the selected material is having the required refractiveness, it does not melt, it does not thermally soften, and it retains its hardness even at elevated temperature. So, that is how the refractiveness also plays an important role. Then coming to the these optical properties. Optical properties are used in both ways, for absorption as well as for reflection, for improving the absorption and for enhancing the reflection. For example, we use lot of solar systems where the radiation coming from the solar will be falling onto the surface. So, part of it is reflected because all the metals will have some kind of the reflection capability, and because of this reflection, heat whatever energy whatever is coming from the sun is not absorbed fully, and a lot of energy is reflected in form of the radiations back. So, coatings are developed onto the surface in such a way that absorption capacity of the surface to absorb these radiations which are coming from the sun can be enhanced, and once this is absorbed in greater amount, then it will be more effectively converted into the heat which is being used for various useful purposes. So, one application of the optical with regard to the optical properties is application of such kind of the coatings or generation of some such kind of surfaces which will be enhancing the surface absorption of the radiations. Roughening of the surface also helps to improve the absorption, that can be another way of modification of the surface for improving the absorption. And then reflection of the radiation. We know that every country wants to safeguard its boundaries from the enemies, and for that purpose like Air Force uses the aircrafts. Aircrafts, there are technologies, electronic technologies where even if visibly, if aircraft is not visible, it can be seen through the use of the suitable radars. So, radars, what they do, they send the radiations, and based on the reflections the object is recognized and its position, size, shape, etc. is identified. So, the technologies are very old, where the radars are used to identify what is which object and where it is. So, what is being developed is the aircrafts are being coated with such kind of the stealth coatings that these coatings reflect the radiations falling onto the aircraft by the radars which are trying to detect the location and position of the aircraft. So, if the radiations are coming from the radars, they will be reflected back by such kind of the coatings. So, stealth coatings basically help to reflect the radiations being applied through the radars to detect the location of the aircraft, and such kind of the coatings help non-detection of the aircraft. So, it can be used for spying purpose by the different countries, and so stealth aircrafts are being developed for this purpose, so that the enemy is not able to detect the location and position of their aircrafts. So, this is about the physical properties. Here now I will conclude this presentation. In this presentation, basically I have talked about the characteristics of the surface and the zones which are found at the subsurface zone in the subsurface region, and at the same time what are the properties of importance which can affect the tribological life of the component. Thank you for your attention.